So in this video I'll show you how to make login ID and password using Python. So let's get started. So here we see that we have created two buffers, user id.pass and .py. So this will be the file where we actually code, and the other one is data.csv. So here we will actually save the all our user ID and password hashes. So what we know is that one of the very good way to save the user ID and password is using the hashes. So hashes are a one-way function, and it kind of does like a string can be converted to a hash, but it's difficult for a hash to be converted back to a string. So it's more secure than an encryption. So let's try some demo on this one first. So let me load up the Python shell, and here I'm going to use the library called getPass, and the getPass for implementing the getting the passwords and all. For the hash, let's look at something. So we'll use the passlib library from passlib.hash import pbkdf2, and we can have several hashes, but I'm importing #256 and let's call it as ps. Now ps dot, you can see there is various methods are there, and let's say I'm encoding some string. Alright, so here you can see that it encoded it into something like this. So the first part of it is what hash it is using, what algorithm it is using. Second part, as we can see, is that it's something like 25,000 is used, and so this is the number of round, this is the cost factor that's there. And the next big thing that we are having is that's the SHA-512 hash that we are using. Now if we run the same thing again, so you can see that almost everything is same, but this part is actually changing. So actual hash is actually changing. So this happens because each time it adds something called a salt. Now whenever we are using something like a salt, so it's like adding some random strings, and by that it's again actually encoding. So this passlib.hash library provides us some very good things, and that is like you can change the salt size. You can actually even specify the salt itself, although we should not do that. So let's try that thing first. So let me make another variable here. So ps using salt equals to, let's say 1 2 3 4 5. It's something I'm choosing random, and let's have our custom ps, and let's hash it with abcd string here. So by default the salt size will be longer, so that's why we are seeing a longer string here. And if we say we choose a different salt, so this string actually will change. But right now, since our salt is not a random function, it's the same function. If we run the same thing again, you'll see that this string is exactly the same. Now let me make another empty salt here, and let's run the same abcd here itself. So you see this time it actually generated by default without using any kind of salt what the string will be. So that it generated this time. Now obviously we don't do that, because if you actually specify the salt, although it's a random thing that you're choosing, but that also can be cracked. So what's better way to do it is, like, instead of using any salt like this, we will not use it. Rather than we will just specify the salt size, and with that size it will each time select a salt. Now here you can specify the byte of the salt, and if you run it, you will see that the string is quite long now, and so it has selected an 8 bit salt size. Since the salt size is longer, we are seeing a longer hash being generated. Now if you use something like if you double the size here, you can see that the overall size of the string is quite long. Actually, it's kind of matching with what we had earlier, so probably by default the salt size is 16 that the passlib actually uses. Now you can do even more things here. So for example, not only I'm choosing the salt, say I choose a salt size as 32, as well as I'm choosing how many rounds. So by default this round is 25,000. Let's make it something like 50,000 and have this ABCD pass itself. So since the size is 32, the hash itself is quite long, and as you increase the rounds, you will see that generating this hash will take more and more time. So let me try that one. So you see it took more time than generating with the 50,000. So if I increase it even more, so it will take more time to compute this hash. So you see that the time it took is significantly more than what we were having. So that's a good thing about the rounds thing. Like it's actually a cost factor to it. So when we have a cost factor like this, so as we go up in rounds, our hash will take time to generate, and as it takes time to generate, it will be harder for anyone to crack. So let's say if I have something like a million or something, it will be significantly taking more time. Yeah, as you can see, it took a really long time. What's recommended these days, if you are having, let's say, SHA-256 or something, you can go for something like 100,000 or something. That should be fine enough. So by that, generation will not take too long, as well as the hash will be a bit stronger. So that's about the basic introduction of the hash function itself that we will be using for building our user ID and password. And in the next videos we will be actually demonstrating on how to make this codes and everything, and we will make the functions, we will make the adding a new user, we will check, verify, and we will do that using the simple Python script. Okay, thanks for watching, and hope you liked it, and stay tuned for the video series. Thanks. Bye bye.